using Newton's method today. By using Newton's method, you can find an approximation of a point using a function. Today we're going to be using the function x squared minus 5. The derivative of that will be 2x. By doing so, we use Newton's method to approximate the points x1, x2, and x3. We come over here. When you already know what your x1 is, to find your x2, you do x1 minus, using x1 into the original function, divided by the derivative with the x1 inside, and the same can be said of your x of 3. Set to equal your x of 2 minus so and so. So here, like I said, we have our function x squared minus 5. The derivative is 2x. And here, we already have our x1, which is nice. So, just like I showed you over there, you find your x2, you equal to 2 minus, plug 2 into the original equation. There you'll have 2 squared minus 5 divided by, and you have your derivative, which you take your 2 times 2, which will equal to 2 minus negative 1 over 4, which is 2 1/4, which is also known as 9/4. Now, when you're trying to find your x of 3, you will take your x of 2, which in this case is 9 divided by 4. You will subtract it by using your original equation. Use your x of 2 and then squared, minus 5, in parentheses, divided by, take your x of 2, plug it into the derivative, which gets you that. Okay, go down here, do some math. That's 81 divided by 16 minus 5 divided by 9 squared. The reason why it's 9 squared is 2 times 9/4 is equal to 9 squared. So you can go ahead and sum that up. Okay, and now in order to make this easier, we're going to go ahead and multiply by 16 on top and bottom in order to get rid of that 16 right there. When we do this, we get 9/4 minus 81 minus 80 divided by 72. And again, we cannot subtract these two without them having a common denominator. So we need to find a way to make 4 equal to 72. We do this by multiplying by 18. However, rules saying what you do on the bottom, you must do on the top. So then you have the x3 point is equal to, or approximate to, 162 divided by 72 minus 1 divided by 72, which is just 161 divided by 72, which is approximately the square root of 5. So then we find our 3 approximations. Our x1 is equal to 2. Our x2 is equal to 9/4. And our x3 is equal to square root of 5. And those are your 3 approximation points. One more example of Newton's method. Here we're going to be taking the function x cubed minus 5 and use Newton's method. The derivative of this is 3x squared. The constant goes away. You bring the exponent down, and minus 1, which is 3x squared. Okay, we're going to go ahead and say we know what our x1 is approximately. We're going to say it's approximately 2. So then, as in the other example, we're going to go ahead and find our x2 point. Plug in 2, minus, you take your 2, plug it into the original equation, take it over here, 2 cubed minus 5 divided by, take the 2, put it into the derivative. Now 2 squared is equal to 2 minus 3 divided by 12. Now we can simplify this and make it a little bit easier on ourselves. Now it's 2 minus 1/4. When we subtract that, x2 is now approximately 1/3. Okay, now we want to find our x3 point. So, just like as we did in the other example, we have our x2 here. here from the original equation. Plug that in. Make sure you have kept your cubed minus 5 divided by, take your derivative, plug in your x of 2, and your derivative is squared. Okay, and then you do some math, or with the calculator, you get 1 3/4 minus, over here you're going to have negative 293 divided by 64. Now note you have a negative here and a negative here, so that's actually going to be positive. Okay, and then divide by over here, this is actually 27 divided by 16 after you do your math. You do some more math, and then you get 1 3/4 plus 293 divided by 108. Because remember, two negatives, you will get a positive. So now our x3 is approximately 187 divided by 54 after you add these two. So now we have our three approximations. Our x1 point is at 2. Our x2 point is approximately 1 3/4. And our x3 point is approximately 187 divided by 54. And those are your approximations for the equation x cubed minus 5.